Assalamualaikum and hi. My name is Muhammad Zain Afan Bezana Abidin, CA20092. For the exploration task, I will explain about Border Gateway Protocol, or we call it BGP. For definition, BGP is the postal service of the Internet. BGP is responsible for looking at all of the available paths that data could travel and picking the best route, which usually means hopping between autonomous systems. When and how is it used? Border Gateway Protocol is used to exchange routing information for the Internet and is the protocol used between ISP, which are different AS. So what is AS? AS stands for Autonomous Systems, which is a collection of connected Internet protocol routing prefixes under the control of one or more router network or more network operator. So this is the graphical representation of BGP. As we can see here, there is two options, option 1 and option 2. So we can see here, there are 6 AS and AS1 need to reach the AS3. So for the option 1, AS1 hop to AS2, it count as hop 1, and for the hop 2, it reach the AS3. So there is 2 count of hop. For the second option, AS1 hop to AS6 and hop to AS5, hop to AS4, and hop to AS3. So the number of hop is 4 for the option 2. So as we can see here, the option 1 provides less, the option 1 provide less hop compared to option 2, which is more efficient, more efficient for option 1 if we use it. So we can see how BGP is actually very helpful in BGP is very helpful in making sure that the hop required to reach the destination between AS require less hop. So who operate BGP autonomous systems? It typically belongs to the Internet Service Provider, ISP, or other large organizations. For example, tech companies, universities, government agencies, and scientific institutions. Each AS exchange routing information must have a registered autonomous system number, or we call it ASN. Internet Assigned Number Authority, IANA, assign ASNs to Regional Internet Registry, IRR, which then assigns them to ISPs and network. So this is how ISP get all the information. So there are 2 types of BGP, which is internal BGP and external BGP. Routers are exchanged and traffic is transmitted over the internet using the external BGP, or we can call it eBGP. Autonomous system can also use as an internal version of BGP to route through their internal networks, which is known as internal BGP, or we can call it iBGP. So using internal BGP is not a requirement for using external BGP. Difference in iBGP and eBGP. First is route advertisement. For eBGP, a route learned from an eBGP peer will be advertised back to another iBGP or eBGP neighbor by default. Meanwhile, for iBGP, a route learned from an iBGP peer will not be advertised back to another iBGP neighbor by default. Which means eBGP is better because it advertises back to another iBGP or eBGP neighbor. Meanwhile, for iBGP, it is only internal and it will not advertise to another eBGP peer. For time to live, eBGP, by default, eBGP peers are set with time to live 1, which means neighbors are assumed to be directly connected. Meanwhile, by default, iBGP peers are set with TTL 255. which means it is not directly connected. Then for scope, eBGP is used between organization and internet service provider. Meanwhile, for IBGP, it is used within the same organization, which means eBGP is more large scale compared to IBGP. For NetScope attribute, eBGP NetScope is changed to local router when it is advertised to eBGP peer by default. Meanwhile, for IBGP, NetScope remains unchanged when route is advertised to IBGP peer. Next, for the topology. For eBGP, it doesn't require full mesh neighborship. Meanwhile, for IBGP, it is require full mesh or S, either of root reflectors or configuration. And as we can see here, this is the graphical representation of IBGP versus eBGP. So we can see here, there is 3 router, router 1, router 2, and router 3. And the circle here represent the AS, or we can call it autonomous system. So as we can see here, router 1 and router 2 are internally connected in AS1, while R3, router 3 are not internally connected with 2 of them, and it is standalone in AS2. Which is why we can see here, router 1 as it is alone, and it is externally connected to router 2, thus to router 1. While for router 1 and router 2, it is internally connected, and that's why it is called IBGP. While the router 3 and router 2 is called eBGP because it is not in the internal network. So for the advantages of BGP, it offers network stability that guarantees routers can quickly adapt to send packets through another reconnection if one internet path goes down. Next, it makes routing decisions based on path, rules, or network policies configured by a network administrator. The quality of the passing to each router so that the connection established has the best possible latency and stability. Also, the cost to implement on big organization is very low to implement the BGP. Next is the disadvantages of BGP. First, and the common problem is that it is vulnerable to attack based on misinformation. Malicious actors can flood a router with bad packets. For example, is denial of services, or we can call it DOS. So DOS is the most common attack that BGP has always faced the problem with. Because the root sharing function of BGP relies on trust, and autonomous systems implicitly trust the routes that are shared with them, which is why another root sharing function cannot predict each of the other router and traffic that are shared with them. Also, it can potentially result in more complexity in router updates and may require more hardware to compute signatures. So for reflection, BGP primary purpose is to route internet traffic, not to ensure the secure delivery of that traffic, which means that BGP is not primarily to secure the network. It just to make sure that the internet traffic routes better. Next, accidental misconfiguration of BGP can interrupt internet connectivity and create havoc. Which means if you misconfiguration the BGP, it can send the route to another traffic that is not supposed to go, and it will cause a security problem and cross-havoc. BGP can ensure that routing is established efficiently and helps to decrease latency between each router. That's all from me. Thank you.